We're back for one more round. But now we're going to move on to set theory. And we're going to answer these 6 questions. Shouldn't take us too much time to answer them. So who knows? I might do another one. So number 17 says, it says write the sample space for the given experiment. And I just want to read them real quick. I think 17 through 19. 17 through 20 is basically kind of the same questions. Okay. Number 17. It says, for an ordinary die is rolled, which is a 6-sided die, or dice, but the singular version. The sample space known as the set S, which I'll denote all my sample spaces, is going to be the set of natural numbers starting from 1, counted up, and including 6. Because a ordinary die is a 6-sided figure. It's a cube, actually, with painted spots on each number, each side, with a different number. Now, number 18 says a coin is tossed and then a die is rolled. So I'm going to do number 18 below. So number 18 says a coin is tossed, then a die is rolled. A coin has 2 sides. It has heads for H, T for tails, while my die has 6 sides. In a question like this, usually I'll recommend using a tree diagram or a table to create the sample space. And for this particular question, I am going to use a table. So I'm going to create my table to the best of my abilities, of course. I'm going to give this table 3 columns. Let's call this 1, 2, 3, 4, 5, 6. This will be my die. And this up here is going to be my coin toss. So it's going to be my coin. And my options for my coin are heads and tails. And then we can write the sample space out and roster notation. So the coin is first, so I'll put a 1 here. The die is second, I'll put a 2 here. So one outcome I could receive is tossing a coin, landing on heads, and then getting a 1 when I roll the die. That is the outcome of H1. So I'm going to call this my set. And I'm going to list it like this, H, 1. So I should write it like that as well too. You can have heads first, and the die rolls a 2. So that's the set of H, the option of H2, the outcome of H2. Heads, then a 3. Heads, then 4. Heads, then 5. Heads, then 6. And then you can repeat the same thing with the tails. Tails receiving a 1. Tails receiving a 2. Tails 3. Tails 4. Tails 5. And tails 6. So let's list those out. And then we have tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. I want to write this better, actually. Make this more neater. So H4, H5, H6, tails 6 goes down here. Close that set up. Make my T's look more legible. And voila. That is my sample space for when I toss a coin and then I roll my die. Number 19 says, a card is selected from a deck and its suit, and then a coin is tossed. So number 19, we're also creating a sample space. So we're going to look at the card suit and then the coin toss. Card suits are diamonds, hearts, spades, and clubs. Once again, for our coin toss, that is heads and tails, where in this case, the card suit is being chosen first. So I'm going to write the sample space out. Maybe it's written different than the answer key, but I'm going to give you the general idea of how this should look. So when we have our options, we can have diamonds being the first suit, and then heads being the first coin toss. So that's going to be the outcome of diamonds, heads, diamonds, tails, that's going to be hearts, heads, hearts, tails. Go down here, hearts, tails, spades, heads, spades, tails, club, clubs, and heads, clubs, and tails. And there you go. Sorry for the handwriting, but hopefully you understand the idea. Now, for number 18 and 19, there's also a technique that you learned on how to determine how many possible outcomes you have. And that's known as the fundamental counting principle. So we can use the fundamental counting principle to determine how many outcomes we have. I know the question says, like, give the sample space, but let's also have a way to verify we have the correct number of outcomes. So for the coin, a coin has two outcomes, heads and tails. A die has 6 outcomes, 1, 2, 3, 4, 5, 6. By the fundamental counting principle, for each event, we can multiply the number of ways each individual event can occur to find the number of ways the event can occur as a sequence. So 2 times 6 is 12 possible outcomes. And when we count the possible outcomes for the sample space for question 18, also I do want to box the final answer, there are 12 possible outcomes. Did I box it up here too? Let's go up here and box 17. And the same thing for number 19. There are 4 suits in the deck. So suits. There are 4 suits in the deck. And once again, there are 2 options you can have when you toss a coin, heads or tails. And the final number of outcomes we have, we multiply and we get 8. 8 possible outcomes. But once again, I do want to box the final answer. I'm going to leave it here. So there's going to be questions 18 through 20. And we do 17 through 19. and we'll do 20 to 22 in the next set of videos. All right, guys, I'll see you in the next one. Take care.